right, this lesson is going to be heavy on the interpretation of graphs and being able to read them. Okay, so for those of you who are still working on your homework, I do need you to shift gears here and switch over. Just close that out and then go back to your notes, okay? Because this is going to be a heavy visual. We're going to be looking at graphs and learning how to read what the story that these graphs can tell us. All right, so for example, this is the graph of a position. Okay, this is a low-level graph. This is supposed to be quote-unquote easy, okay, because this is a position relative to time. Time is always going to be on the x-axis here, okay? So you never have to worry about that when we're dealing with this. This is a position equation. And all we're doing is we're reading these, is we're identifying whether the position is above or below the x-axis. It's as simple as that. I don't need to be concerned about what the position is, but what the nature of the position is. All right, so for example, on the time interval between -3 and -2, so that's the little square of time interval over there, I just want to identify, does it have positive position or does it have negative position? Okay, so what would you say right there? Positive. Right, it's above the x-axis. Okay, so that has positive position. And so as you're thinking about that, you would just, okay, all right, positive position. What about from -2 to -1? Okay, so we're talking about this time interval right here, and it had positive position. Then we're talking about this time interval. It also has positive position. That's all I'm talking about. Is it above the x-axis? Is it below the x-axis? Okay, then we get to -1 to 0. Okay, that now the position is below the x-axis, so now that's a negative position. And for every interval, for the next total of four values, 4 intervals, those all stay below the x-axis. Okay, that's a fully negative underneath the x-axis. Then I switch. And now I'm going above the x-axis again. Okay, so the next interval between 3 and 4 is above the x-axis. How high it is irrelevant. It's just that it is above the x-axis. Okay, so that's a pretty easy, yeah.
Just a conceptual question, but I thought that position graphs can never have components. I thought they always have like a curve thing or like a fillet.
It depends on, no, not necessarily.
I think that I could have acceleration velocity.
Okay. This graph won't be differentiable. Okay. Yeah, you're right. It's not going to have a derivative, but we can still do. Okay. We're just doing a conceptual problem right now. Yeah.
The little chart thing at the bottom is BUT. Wouldn't that mean velocity now?
Okay, yep, so you're just jumping the gun. You're on me a little bit. Okay, so my next thing, now I'm going to go back. You guys have, so Notability can help us do all of this, okay? Oh, shoot. Once I've changed my pen, I can't go back and erase any of that. Shoot, you can clear all that out. Okay, I can't.
Are you going to explain everything?
Yeah.
There's a second.
I know. It won't let me do it. The bottom eraser?
No, the middle one.
Yeah.
Won't let you do it? Oh, I've never had that.
Happens to me all the time.
I feel like it's set. You guys have starting setting.
That's weird. Mine lets me do it all the time when I change.
Yep. No. Okay. All right. So now, after we're reading this, what I was gonna do next is fill in the velocity. So erase all of your position things. Now we're gonna do the same thing with whether the velocity is positive or negative. Okay, and velocity has to do with the slope or the slant of the position graph we're reading. So if we go back to the same interval right here, okay, from -3 to -2, what kind of slant does it have? Or, okay, it has a positive slant, so it's positive velocity, okay? And then you go to the next one, and you want to know what its velocity is, which is the same thing as knowing its slope. And now it has negative slope. Okay, and then it continues to have negative slope until what happens in this interval right here between 1 and 2? What kind of slope does it have? It doesn't have positive slope, and it doesn't have negative slope. What kind of slope? It has 0 slope. And then from 2 to 3, it tilts to a positive slant or positive slope again, and then positive slope. And then between 4 and 5, we have another horizontal piece, so we're at 0 values. And then its slope is negative the rest of the way. Okay, so those are the velocity values reading that. Yeah.
So
So velocity is the second row, and then.
Yeah, you should erase your whole first row. You should only have one row. I can't. I'm just gonna. I thought I was gonna be able to, but I can't. You should only have one. Okay, so this tells a story. Okay, when velocity is positive, what is the object doing? How is it moving? Forward, or it could be moving up. Okay, and when the velocity is negative, then the object is moving backwards. Okay, we don't know it's slowing down. We do not know that it's slowing down. We only know what direction it's going. Okay, so we have a forward, followed by backward for a little bit, and it's backward this whole time until it gets to 0. And what's it doing when it's 0?
Not moving at all.
Not moving at all. It's just sitting there. Okay, very still. Okay, and so then it's still. Okay, then we have forward for those two, and then still, and then backwards. Okay, so we can tell almost a little story or a little biography of what's going on with this. We don't. Is it a bug? Is it, you know, what's the object? Is it the robot that's moving? What are we doing? Okay. If we want to draw the velocity graph, you actually have to calculate the slope. So I've done that already, and I've calculated what the rise over run is for every segment. All right, so for this first one here, I've calculated that the segment is 1. So if I want to draw the velocity graph on top of that, I will draw a segment value that has a value of 1 for that entire segment. It should have a closed circle on the left, but it should have an open circle here because, as Isabella pointed out earlier, there's a corner there. Okay, then for 3 consecutive intervals, I now have a calculated value of -1. So I drop down to -1, and I have a consecutive slope value with open corners with a value of -1. That's the time where it's moving backwards. Then it has a time of rest where it's not moving at all, which means I have an open segment of 0. Then it has 2 segments with a value of 2. And so I'll go up to a value of 2, and that's 2 segments long. Then it has another value of rest. And then it finishes with 2 segments with a value of -1 because the slope value is -1. And then I end with a closed circle. Okay, so that's the drawing of a velocity graph from off of a position graph. Okay, the only thing you have to do to make that a speed graph, go ahead and copy that with your Notability. Okay, and then copy and paste it and slide it over and translate it onto the other graph right next to it. Okay, once you've translated that over, okay, then you should take all the negative pieces and just make them the equivalent of their positive value because the speed is simply an absolute value. So everything that used to be -1 should now be +1. So your graph is going to look a little bit different. But you still need so you're going to have a +1 piece connected with an open circle. And then the next long piece is going to be +1 also, but keep the open circle. Okay, because there's still a corner there. So the speed graph is going to look like that. And then we still have rest. Rest is fine because rest is not negative. And then a value of 2. And then the rest value again, and then the value of +1 to finish it out with a closed circle. So you're just sliding those pieces up above the x-axis, okay? So this is velocity, and this is the graph of speed. Okay, any questions so far? But this is a very jerky thing. Okay, it's forward, it's backwards, it's still, it's definitely not smooth. This is very jerky. Okay, now here's where it gets a little harder. What if now you're told the graph you're looking at is a velocity graph, not a position graph? Okay, it's a velocity graph itself. Okay, then the way we read it is a little bit different. If this is velocity itself, then its positive and negative nature isn't found by the slope, its positive and negative nature is just found whether it's above or below the x-axis, because it's already a velocity graph. And so again, just interval by interval. Okay, if I'm looking at this square right here, okay, those values are found below the x-axis. So I'm going to put a negative for my velocity. But the slope of that piece is negative as well. So that section has both negative velocity and negative slope, and the slope of the velocity is the acceleration, or the derivative of the velocity is the acceleration. So this has both negative velocity and negative acceleration. And the story is, when something has both negative velocity and negative acceleration, what is the feeling you're experiencing? Speeding up, not going towards. Towards has to do with position. Okay, so this would be speeding up. Okay, because of the matching nature of the velocity and the acceleration. All right, the next little square, if you just go square by square, that's still below the x-axis, but the slope of that is now positive. So that has negative velocity, positive acceleration. The feeling of that will be slowing down. Okay, then I go to the next one, and I'm just going one by one. Okay, now I'm above the x-axis, which means I have positive velocity, but the slant in there, the slope of that is still positive. So now I'm back to speeding up again, because I've got matching signs. So this is also speeding up. Okay, also the next two, which are right, that next one, above the x-axis with a positive slant, speeding up. Okay, the next one. Okay, this next one is still above the x-axis, so I put a positive here. But then what do I put in for the acceleration? Put in 0. Okay, and when the acceleration is 0, do you know what the feeling is then?
Constant speed.
Okay, you're coasting. Okay, feeling of constant speed. You're not speeding up or slowing down, you're just going steady. Okay? All right, and then the next one is now rectangular because the slope has changed. It's above the x-axis, but it has a negative slope. Then the next unit is below the x-axis with negative slope, and that would be, again, an opportunity for speeding up. So we'll identify that as coasting or constant. And then we have speeding up again. So an example of a question you might get asked: identify all the intervals that are speeding up. Usually people can always get this one right here. Okay, they would say that that's speeding up because it's above the x-axis and it has positive slope, and almost everybody can get that one right. It's usually ones where it's below the x-axis with negative slope that they'll miss. Okay, then we have another minus with a 0, so now we have a coasting opportunity again. And then our last two are below the x-axis with positive slope and below the x-axis again with positive slope, and so that would be a slowing down opportunity. So you can tell the story. Okay, from time -3 to -2, my object was speeding up, and then my object was slowing down, and then it was speeding up again, and then it was coasting for a little while, and then it slowed down, and then it sped up again, then it coasted a little bit more, and then finally it slowed down at the end. Okay, you can just experience and put it all together. Any questions so far on that? Okay, so here is that those same values, I just copied them over. Now you ask the question, when does the particle change its direction? Okay, so every time the particle changes direction, you want to look for changes in velocity. Okay, not changes in acceleration. Direction is directly connected to the velocity. So a change in direction is going to happen every time the velocity changes nature. And so the first change in direction happens at what time? -1. And the next change in direction would happen here where I have a positive changing to a negative. So it's like jerky motion, but now I'm changing, maybe I was going right and now I'm going left. Changing direction again, and that would happen at +3. Okay, so only changed direction twice. When is the particle going to the right? Okay, it's going to the right anytime we have pluses in our velocity. And so going to the right would be all of these positive velocity units, every single one. And so the right, and you can put them all together, would be from -1 all the way to +3. Please don't put equal to bars underneath. Okay, why? Because you just told me in the problem before that it was changing direction at -1 and 3. So it can't be changing direction and going to the right. It's not both. Okay, these are always open intervals without the inequality. Okay, to the left would be any time the velocity is negative. So that would be from -3 to -1, and again from 3 all the way to the end of 7. Okay, stopped. Please don't confuse stopped with coasting. Being stopped has 0 velocity. Coasting has 0 acceleration. So when you are stopped, you have 0 velocity. Okay? We presume that that is happening at -1 and 3 because that was when it changed direction. Now that stopping is not like a permanent full stop. It's like a stop sign stop you come to and you're like, really, officer, I stopped. Truly, I did. Okay, it is stopping instantaneously, just long enough for the particle to change direction. This is not a full long stop. It is an instant and a moment when the particle, but in order to change direction, they had to have stopped, even if it was just for a millisecond. Okay, how are we doing? Okay, again, same data. I just copied it down. We've already answered the speeding up questions. Okay, so I'll just do that again. I'll underline speeding up in red, and then I'm going to identify the speeding up, okay, from this graph here. Okay, so Kaylin, can you give me a speeding up interval?
-3 and -2.
Why?
Because they're both the same sign.
Yep, they share the same sign. Okay, so I'll do those in red. Okay, Rain, can you give me another one? Yep, and the one right next to it as well. So we can group all of those together. So I would not just say -1 to 0, but I'd go -1 all the way to +1 and include that. Okay, Chloe, are there any more where it's going speeding up? Yep, okay. All right, and then we'll identify the slowing down in blue. Okay, so we've identified those slowing down regions. Okay, so those will be our slowing down, and this we can group those two together because they're all slowing down. And then our coasting, we've already talked about that. Coasting would be any time the acceleration is 0. All right, doing okay? Okay, the charts are really going to be helpful to you. It takes time to make a chart, but once you're done, it's like you can answer questions really fast if you've got that worked out like that. Okay, so now we're going to make a chart from something that has curves. Okay, but just do it one section at a time again. Okay, so let's just look at this first interval here, and I just that's where I'm focusing on. Okay, this is a velocity graph. That section is positioned above the x-axis, so the velocity is a positive, and it also has a positive slant or a positive slope to it. I know it's curving, but it's still all positive and going, so that would be a double positive, which would be a speeding up section. Okay, even the little piece right next to it, okay, that little section now from 1 to 2, it still has a positive above the x-axis, and it has a positive curve to it. In fact, sometimes I just like to do all the velocities right across the row. Okay, this thing stays positive all the way until I get to what interval? Okay, until I get to 6 to 7. 6 to 7 is the last time that it's positive, and then it changes, and then I'll have a minus for 2 intervals long, and then it's back to positive. So sometimes I like to do it that, just to get all my velocities done at once. Okay. Okay, does anybody want to take the acceleration row for practice? Okay, rows. So from 2 to 3.
Negative.
Okay, it's curving, sloping down.
And then
3 to 4.
4, negative.
Okay, 4 to 5.
0,
5 to 6.
Zero.
6 to 7.
negative.
Okay, 7 to 8.
Negative.
8 to 9.
Positive.
And 9 to 10. Good job. All right, so she's just following whether it's curving down, sloping down, or staying constant, and then changing again. And now from that, we can answer all the same questions that we were doing before. Okay, so all these values, you can go ahead and slide on to slide number 20. All those values are copied over for you. Okay, so Juliet, when does the particle change direction?
At 7. And 9.
Okay, so, and why?
Because the velocity changed like positive.
Okay, so the velocity change is sign. Another way to say that is the velocity changes nature. Nature would be the same thing as sign. Okay, so that, and you're going to have to answer and why. Okay, because the velocity changed nature or changed sign. Okay, all right. Jonathan, when's the particle going up?
When T is from 0 to 2.
0 to 2. Okay, does anybody else think there's other places this is going up?
9 to 10.
Okay, I think you guys are answering the speeding up question. Going up is different than speeding up. Okay, when is it going up? 0 to 7. Okay, when is it going down? 7 to 9. And what about after 9? Back to going up again. So then I have 9 to 10. Okay, so we're only checking velocity for going up. Now, when I want to check speeding up, then I do the comparison and look for things that are the same sign. Okay? All right, Nick, so when are we going to presume that it's stopped? Instantaneously, just for a fraction of a moment. Okay, 7 and 9. Because? How can you infer that? Okay, the velocity is switching signs there. Okay. All right, I've copied it over here. Okay, so Jonathan, we can punt it back to you again. Now, when is the particle speeding up? So you may have been ahead on a slide, I don't know, but when is the particle speeding up?
0 to 2.
Okay, so speeding up would be 0 to 2. Any other places where you see it speeding up?
8 to 10.
8 to 10? I don't think it's 8 to 10.
9 to 10.
9 to 10, okay. So why do you think it's speeding up in those areas?
Because the slope and the velocity are positive.
The velocity and the acceleration are positive. Okay, any other places? Bella?
7 to 8.
Why 7 to 8?
Because they're the same sign.
Okay, they're also the same sign, and so it's also speeding up. It's going a different direction, but it's still speeding up. Okay, and then let's compare that to slowing down. Okay, Julie, you want to try that? When will it be slowing down? Okay, anything more than 2 to 3? Okay, so let's combine those together and say 2 to 4. Okay, anything else? Okay. And why? Okay, so again, don't say they have different signs, because we're going to be talking about like 3 and 4 things at once, and I don't know which they you're talking about. So be specific, because the velocity and the acceleration have different signs. So, because we're going to start talking about other things too. So make sure you don't use it, don't use they. Be specific. Okay, the particle coasting, Sydney?
4 to 6.
Okay. And why?
Because the velocity or no, because the acceleration is 0.
Okay, because the acceleration is 0. Great. All right, any final questions about that? All right, 2:30.